Hello, this is Patrick from Prover, here to give a quick demonstration on Prover Station, our new product, either by fully using digital twin aggregates in this system or using physical hardware in the loop. For this demonstration, I'll be going quickly over station development with iLok, just showing you two of the stations that we have as part of this demonstration. I'll then be giving a short introduction on Prover Station itself, how to add logical elements to the loop, and what the graphic user interface looks like from a user standpoint. Then I'll be starting a simulation with Prover Station, going through a brief set of tests with Test Bench, and that will be with all parts of the station being used with digital twin aggregates. And then after that, I'll show you how that looks, how we switch from the fully digital twin aggregates into using physical hardware in the loop as well, and doing a bit more with Prover Test Bench. So let's get started with a brief introduction to station development with iLok. Now, the use of Prover iLok in order to develop individual stations leading up to the development of the entire line is outside of the scope of this particular demonstration, but we do have demonstrations on the Prover website that show how to use Prover iLok and its functionalities. The important thing here with Prover Station is that in order to use Prover Station, you must have developed the system and constructed a safe or HLL model, such as what can be generated with Prover iLok for each station in your system. These models can then be imported into Prover Station to be used as the representation of the system. What we at Prover tend to use Prover iLok for is for generating these individual stations, using it for quick requirement verification, ensuring informally that safety requirements are met, and to test to ensure that our model matches and is equivalent to client specifications. In essence, Prover iLok is an excellent product to use in order to perform rapid prototyping with low cost to the customer. So, let's move on to a brief introduction to Prover Station itself. Prover Station consists of three main modules: digital twin aggregates, proof projects, and track plans. In this demonstration, we will not be going over anything about proof projects because Prover Station is still at an early level, but we will be going into digital twin aggregates and track plans. Digital twin aggregates is where we'll be setting up our environment, where we'll be uploading the files from Prover iLok to generate a system of stations. We'll be able to connect external simulators or do hardware in the loop testing and investigate consequences of proposed changes to systems from that module. In track plans, we'll be uploading our track plan, the traffic management system that we've shown previously in iLok. We'll be able to view scenarios of falsified requirements, view what happens during simulations, and connect track plans to external simulators or hardware for monitoring. So let's start with the track plans. I've already uploaded the track plan that I showed before in iLok here, the one with Station X and Station Y. This is the exact same traffic management system shown in iLok, simply uploaded into Prover Station. Right now, it's very bare bones. We can't do much with it right now, but it will be important when we start testing the system. We can go back to Prover Station, and now let's check out the digital twin aggregates environment. Here we see both stations, Station X and Station Z, are represented by two twins. One twin is the PLC non-vital logic, and the second twin is the interlocking, or IXL, vital logic. We have these two twins for both stations. We also have a track plan display, which will connect our system to the track plan that I just showed. In addition, we include a digital twin of the track plan logic that will connect the track plan display to the station environments. Each digital twin, let's take a look at Station X, the PLC logic, is composed of three files, all of which are generated from the Prover iLok environment when we develop the stations. We have the safe code itself, which has all of the different variables, equations within that one station, as well as input-output links between this digital twin and other digital twins. So here, for this PLC link, we have an input-output link from station X, the TMS link, so connecting to the track plan, and also a link to station X, the vital logic link, so the interlocking link. In order to add a new twin to this system, it's as simple as clicking a button, writing a name, choosing which kind of representation you want for the digital twin. Prover Station currently handles 4 separate kinds of representations, either external communications via MQTT or OPC UA, or internal communications with HLL files or safe code. Then you just simply click and drag the files to this area to upload, and then you have it ready there. In these digital twins, we use safe representations. You can then delete these twins if you want, if something changes down the line, by deleting them. We can already show the power that Prover Station can have, because in order to represent this purely with iLok, we would require 5 different instances of Prover iLok open, 5 separate windows. 1 for the traffic management system, 1 for each of these digital twins. Here, this is just one window and a second window to show the track plan. As we add more stations to the line, each line would add 2 more applications that we would need to have open, or 2 more additional digital twins. Again, 1 for PLC logic and 1 for the interlocking logic. If we were to use digital twins in iLok in order to do the simulations, we would have to start up individual Docker containers, each holding one of the digital twin aggregates, and use those connecting to an interactive simulation of the track plan in order to run interactive simulations or to run test bench scenarios. With Prover Studio, it's as simple as clicking on the Start Simulation button. Here, everything is being represented by digital twins, but you can already see everything is running. If we move back to the track plan, you already see that the initialization procedure for these 2 stations has already started up. Once the system has finished its initialization procedure, we can then continue to further testing. Within Prover iLok, you can export a series of test cases called Test Bench to test a repeated number of tests across each variable within the system. These tests contain tests on root functionalities, switch functionalities, emergency function functionalities, and more, based on the modeling of the system. We can start these series of tests currently through a command line interface, though future versions of Prover Station will allow these test bench runs to be started from within the user interface window. The test bench files will start by initializing the system, as it did before, ensuring that the entire system is set in one state, where everything is unoccupied and good to go. Once it is done, the initialization procedure, it will then start progressing through each test. In this case, it starts by simulating a route request, followed by a train going through the route. With Prover Station, we can also quickly change which kind of representation we want each twin to take. Here, I've set up a system where we have a physical PLC, a Schneider M580, is attached into the system here. If we wanted to include it in our representation in Prover Station, all we need to do is change which kind of representation this takes. I've already set this up to be an external OPC UA communications system, which is due to the fact that the M580 includes an OPC UA server and will receive and send out OPC UA publications. This external OPC UA server will communicate through a digital twin MQTT OPC UA bridge, which is a digital twin representation with a specific endpoint and namespace. This PLC logic will be used only on the hardware attached to this system, in this case connected to a PC. We can then start the simulation just as before and move over to the track plan layout, where again the track plan will undergo the initialization procedure. We can then, just as before, start up our test bench run, except now, instead of having everything be a purely digital twin representation, we now have the Station X PLC logic actually being run on the physical hardware that it will be run on site. And just as before, we'll start running through every test scenario. These tests are vital because it ensures safe operations on site with actual hardware. These large-scale tests show the potential of Prover Station to our customers. We're able to more easily simulate entire line systems and test for optimization capabilities, stress test lines, and understand potential problems or unsafe circumstances before they can occur. We at Prover see testing a railway in 2 steps. The first step is developing and testing the subsystem through the use of Prover iLok. This is very much supposed to be a developer tool in order to set up the stations and test for safety and reliability from a station itself, with possibly bordering stations there. Once each station has been generated and developed in Prover iLok, as well as the traffic management system, we can then export those and put them into Prover Station to test for full line capabilities and also perform system tests with hardware at the end. We can test situations like simulating peak traffic conditions, unexpected operational events, maintenance protocols and their impact on the line, and include real hardware in this loop to ensure that everything is working before installing them on the line. In essence, Prover Station does not act as a replacement towards Prover iLok, but instead complements it. iLok is early stage design and verification, Prover Station for full line scaling. With these 2 products, we hope to enable automated validation pipelines for digital-first strategies in order to lower costs, better verify, and catch problems early. Thank you very much for your time, and I hope that you have a better understanding of what Prover Station can be used for.